In this video, we're going to talk about exponentiation for rational exponents. If you think back to your definitions of sets of numbers, a rational number is a number that can be expressed as a ratio of two integers. That means that so far we've been working with just integers as our powers, but now we're going to work with negative integers because those are rational. We're going to work with 0, and we're going to work with fractions as well. So let's start with negative exponents. These I've already actually referenced, but I want to write it explicitly in this video. If I have x to the negative n, that is simply equal to 1 over x to the n. The reasoning behind this is if you think back to the quotient rule, right, where I said x to the a over x to the b is equal to x to the a minus b. Well, let's see. If I have 1 over x to the n, I could write this as x to the 0 over x to the n. 0 minus n is negative n, so I have x to the negative n. So this is how you know that this little bit is true here. Okay. If I have x to the 0, this is another thing I've kind of mentioned before. X to the 0 is equal to 1. Any number raised to the 0th power is always going to be equal to 1. So these are the two that we've talked about before, but we're going to be using a little bit more of now. The one that we haven't talked about yet is fractional exponents. So if I have x to the 1 over n, this is equal to the nth root of x. So if I had x to the 1/2, that's actually another way to write the square root of x. What if I have instead x to the a over b? Well, okay, if I have a over b, remember that our rule here, if I have a power to a power, I can multiply them. So I could write this as x to the 1 over b times a, right? Or x to the 1 over b raised to the a. So really, this is just going to be the bth root of x to the a. Or you could think of it as the bth root of x all raised to the a power. Okay? So let's look at some examples of how we use these properties. Let's do example 1. Suppose I have something pretty involved. I have 2x to the 2/3 power times y to the negative 6 times z to the 0, all raised to the 4th. And I have that divided by 4x squared y to the 10 z to the negative 4. How do I simplify this? Okay, well, what I'm going to do first is I'm going to recognize that, hey, z to the 0 is 1. That just goes away. So I have on top 2x to the 2 over 3 times y to the negative 6 times, we got rid of the z, to the 4th, divided by 4x squared y to the 10th z to the negative 4th. Then what I'm going to do is I'm going to distribute this power in here. And just because I have a fraction, it doesn't change how a power to a power works. I'm still going to have 2 to the 4th, which is 16, times x to the 2/3 times 4 is 8/3, times y to the negative 24, divided by 4x squared y to the 10th z to the negative 4th. Well, now I can think about how I described negative exponents, where I can just bring the stuff down, right? So what I can do from here is I can say, okay, 16 divided by 4 is 4. X to the 8/3 minus 2, so I can get a common denominator here, right? 2 is just equal to 6/3, so that's going to be 2/3. So I'm going to have times x to the 2/3 divided by, because I'm going to have negative 24 minus 10 is negative 34, which means I can put that in the denominator and say it's y to the 34. And z to the negative 4, this is just 1 over z to the 4th, which means this can get moved to the numerator. So I have z to the 4th. So remember, if you have a fraction, you have a negative exponent in the denominator, you can just bump it up to the numerator. If you have a negative fraction in the numerator, it goes down to the denominator. So you just kind of flip it. Let's look at another one. Let's say I have 3 to the negative 2, and I want to know how I can write this. this is, and then obviously this is much, much easier. I just kind of want to demonstrate. So if I have 3 to the negative 2, right, I can write this as 1 over 3 squared, which is 1 over 9, right? But if I have 1 over 3 to the negative 2, and this is what I was just talking about, where if you have a negative in the denominator, you bring it up, then this is really equal to 1 over 9, right? So this is 1 times, or divided by, sorry, 1/9. And remember, to divide two fractions, you multiply by the reciprocal. So this is 1 times 9, which is 9. Okay? So in this case, you bring it up. In this case, you bring it down. And that's how negative exponents work. In the next video, we're going to talk about powers and radicals without calculators. So we're going to be using this property here to do some calculations with actual numbers.